2022 Grade 12 Euclid Math Contest, questions 8 through 10. 8a, suppose that a is greater than a half and that the parabola with the equation y is equal to ax squared plus 2 has vertex at v. The parabola intersects the line with the equation y is equal to minus x plus 4a at b and c. If the area of triangle VBC is 72/5, determine the value of a. Okay, so we're going to need a lot of space, so here we go. So the first thing is I want to draw that diagram again, and let's see here. It was basically a parabola and you had a line. So something like this, right? It's not going to be a work of art, but you get it. And then you had B here, you had C here, and then you had the vertex V, which is right there. Okay. And I guess they want us to figure out some sort of an area and all that stuff, but there's several steps, so let's take this one step at a time. First, the equation of the parabola is y is equal to ax squared plus 2. So let's just label the BC and those vertices, or whatever you want to call them, those main sort of points, V, B, and C. Well, V is going to be on the y-axis, so set x equal to 0. When x is 0, y is 2. So that means the coordinates for V are 0, 2. Okay, that's the easiest one. B, how do I figure out B? Well, B is going to be, I guess, one of the two intersection points of the line and the parabola, right? So I guess we just set those equations equal to each other and off we go. So we've got y is equal to minus x plus 4a, and then you've got this y is equal to ax squared plus 2, so let's set them equal to each other. So minus x plus 4a is equal to ax squared plus 2. All right, so let's put everything on one side, and when you do, you get ax squared plus x plus 2 minus 4a. And that is equal to 0. So I'm going to use a quadratic, and when I do, I get minus 1 plus or minus the square root of b squared minus 4ac, like this, all over 2a. And when you simplify all this, you get minus 1 plus or minus 1 minus 8a plus 16a squared, all under the square root sign. That's, of course, over 2a. And therefore, minus 1 plus or minus. Okay, so this factors pretty nicely. It factors into 4a minus 1 all squared. And that's under the square root sign, all over 2a. And this works out to be pretty decent. 4a minus 1 all over 2a. And when simplified further, let's see here, it will be either 2 or 2a minus 1 over a. So those are the two roots. And then, of course, you can sub it back to any one of these guys to get the y values, the corresponding y values. I'll let you do that. That's pretty straightforward, right? The corresponding y values, when x is 2, y will be, I think it's minus 2, right? Sorry, that should have been minus 2. Sorry about that. Minus 2, y will be 2 plus 4a. And then the other guy, which is 2a minus 1 over a, when you substitute that back into this, or any of them, you will get y is equal to 4a minus 2 plus 1 over a. So that means that b is minus 2 plus 4a, and c is 2a minus 1 over a, and the y coordinate is 4a minus 2 plus 1 over a. So those are the coordinates. They're all in obviously in terms of a. Okay. So now that we have the coordinates, I'm going to go back to this diagram. Now we are asked to discuss or figure out some areas here. Now, how are we going to figure out this area, right? It seems a bit it seems a bit unorthodox, like it doesn't have much of a shape that you could figure out. But the good news for you is that in the question they actually tell you that it's a triangle that they want you to figure out. And in particular, that triangle is triangle VBC. So I guess from V to B, so I guess from there to there, and then from V to C. So that triangle in there is the area that we have to concentrate on. Now, how do we figure that out? Well, what you can do is you can make a trapezoid like that, and that will help you out tremendously. So let's first, instead of making this diagram all messy and stuff, let's just put that trapezoid diagram here. So pretty much the same shape, but this time I've just drawn the shape of the trapezoid. Now, most of you remember that the area of a trapezoid, if let's say the side, this was, let's say, B, and this was A, and this was H, the area is A plus B divided by 2 times H. Okay? So we have to then use these guys, these coordinates, to figure out what is the area. Okay? So here we go. That area is going to be as follows. We have to figure out what is, first of all, the distance from there to there. So that's going to be this B. What is the distance from there to there? That's going to be this A. And then the distance from there to there, which will be my H. And then plug it into that formula. So that's where these coordinates come into play. All those coordinates were done for a reason. So here we go. The first one is going to be 4A minus 2 plus 1 over A. And then it's going to be minus 2. That's going to represent the big one from here to here. And then this one, A, so that's that A is going to be, let's see, on the other side, it will be 2 plus 4A. That's the y coordinate on that guy, minus 2. And then, of course, I got to divide by 2. And then I have to multiply this whole thing by H. And H, let's see here, H is going to be from one x coordinate to another, the x coordinate of C and the x coordinate of B, I guess. So that's going to be 2A minus 1 over A minus minus 2. Yeah. Okay. So that will do it. And that should be all we have. Okay, great. So that's the area. Now, I will let you simplify this, and I've already simplified it. So it's going to be 4A minus 2 plus 1 over 2A, and then multiplied by 4 minus 1A. Well, this obviously can be simplified further, but that's about as far as I can go. Okay, so that's the area in terms of A of this whole trapezoid, right? But there's another way of figuring out the area, and that is as follows. What you do is you break this up into sections. You got 3 triangles, basically. You got this first triangle, this one here. I'll just shade it in, and we'll call that, whatever. I mean, it doesn't really matter. So this is just an alternative way of figuring out the area of that trapezoid. You got triangle 1, right? And then you've got this smaller triangle here. I'll call that triangle 2. And then we've got the main triangle, which is the one in the middle that they are calling VBC. Okay, so that's another way of figuring out the area of that entire trapezoid. Now you can use 1/2 base times height to figure out these guys, and this one they've already given you is 72 over 5. So using 1/2 base times height, let's see what I can get. For triangle 1, the big one, let's see here. Which one should I do first? Well, I guess the bigger one. That would be 1/2 base. So the base is 2. And the height is 2 plus 4a minus 2. That takes care of, well, it doesn't really matter what you called which one. Just it's this one right here, that one. And then this smaller one, that guy, that's going to be 1/2 base times height. So that base is 2a minus 1 over a. And then the height would be basically subtracting the y coordinates. So it would be 4a minus 2 plus 1 over a. And then minus 2. Yeah. Okay. So this guy represents the area of that trapezoid, and so does this. So you set those two equal to each other. Got it? So this and this are equal to each other, and then hopefully that will allow you to solve for A, which I believe is the end goal of this question. So it's a lot of algebra, and hopefully you won't make any mistakes. So let's go. We're going to need a lot of space. So when we set them equal to each other, we have the following. We got 4a minus 2 plus 1 over 2a, and it's over 4 minus 1 over a, or multiply I should say. And that was the area when I did it the first method, which is the trapezoid formula, if you remember. And then this other method, which was breaking it up into 3 triangles, I got this big long thing, which I will simplify actually a little bit. 2a minus 2 plus 1 over 2a and plus 4a. Okay, so basically I set this equal to this and simplify just a little bit. So that's all I've done. Okay, here we go. All right, well, I mean, really, I should let you simplify it, right? I mean, do you really want to listen to me simplify it? Not really. But if you do simplify it, you're going to get a cube. So because it's a little complicated, I'm going to do it for you. So here we go. 8a squared minus 4a plus 1 all over 2a. And then this guy, 4a minus 1 over a. This is 72 over 5. Nothing changes there. This becomes 2a minus 1 over a. This one becomes 4a squared minus 4a plus 1 over 2a. And then we've got this lone 4a over here. Okay, so then just multiply all these guys out, and you're going to have to expand this. So 32a to the power of 3 minus 8a squared minus 16a plus 4a plus 4a. Hopefully I haven't made any mistakes. Minus 1, and then all over 2a squared. This side, 72 over 5. That doesn't change. And then neither does that 4a. And then when you expand this guy, we're going to get 8a cubed minus 8a squared. Oh boy. Plus 2a minus 4a squared plus 4a minus 1 all over 2a squared. All right, great. Well, the good news is that you got this and this whole thing are all over 2a squared. So that's good. You can put it all on one side. And when you do, you get 24a to the power of 3 minus 12a squared plus 2a all over 2a squared. And that equals 72 over 5 plus 4a. So it's working out, right? I mean, it's a little complicated. All right, so add this fraction, and you get 72 plus 20a over 5. I don't think we can do much here. Can we? Yeah, I think we can. We can get rid of 2, so it'll be 12 a to the power of 3 minus 6a squared plus a over a squared. And I guess I could have divided in a as well, but that's okay, whatever. Now cross multiply. You get 72a squared plus, sorry, that should have been a 20. Sorry about that. So 20a to the power of 3, and then this is going to be 10a to the power of 3, I believe. sorry, this should have been a 12. Sorry about that. So that's actually 60. And then minus 30a squared, and then plus 5a. All right, almost getting there. And then I guess put everything on one side. And when you do, you get, is there any a third here? I missed another 0. This should have been a 0 right here. 20. Okay, put everything on one side, and when you do, you get 40 a to the power of 3, and then we get 102, I believe, minus 102 a to the power squared plus this 5a. Okay, now we factor out an a, and when you do, you get 40a squared minus 102a plus 5. Okay. All right, that's pretty good. Let's see if I can finish this off. Well, probably going to need a little bit of space, but I can keep it in the same screen. This equation here, let's see, 0 is equal to a. Does that factor? Probably. Let's see here. I think 20a minus 1, and then 2a minus 5, I believe. Yeah, so that means either a is equal to 0, 1 over 20, or 5 over 2. Now, they told me in the question that a was greater than a half, so that means it can't be that, it can't be that. So the only value of a that is valid according to their rules is the 5 over 2. And there you go. That's the answer. Consider the following statement. There is a triangle that is not equilateral, whose side lengths form a geometric sequence, and the measures of whose angles form an arithmetic sequence. Show that this statement is true by finding such a triangle, or prove that it's false by demonstrating that there cannot be such a triangle. Let's draw a triangle, okay, that is not equilateral. Label it A, B, C, and then let's label the sides. So the sides make a geometric sequence, right? Okay, so that means the sides would be A, AR, AR to the power of 2. That is a geometric sequence. The angles form an arithmetic sequence. So the angles, it doesn't really matter. It would be like theta plus k, theta plus 2k, like that. Got it? So that's basically the angles. Now the angles, we all know that if you add up all the angles of a triangle, they equal 180. Correct? Okay, so let's add them up, and let's set it equal to 180. This means that 3 theta plus 3k is equal to 180, and therefore theta plus k is equal to 60. So that basically means that this middle angle is 60. So that's great. We got a numerical value for one of the angles. So the other one is basically 60 plus k. And this one over here is 60 minus k. So let's put that in. It doesn't really matter where you put it. This is just an illustration. So this first guy in here will be 60. This guy will be 60 minus k. And this guy up here is 60 plus k, the angles. Okay, so that's the initial setup of the question. Okay, so now we use something called the cosine law. And you guys remember the cosine law, right? And we're using it on this triangle. So let's use the cosine law. So that means AC squared is equal to BC squared plus AB squared minus 2BC times AB cos of that angle, which is angle ABC. ABC. Yeah. Okay. Now let's work with this cosine law and see what happens. Let's see if this works out. If it works out, then we've proven that there is such a triangle. If this cosine law does not make any sense at the end, then it shows that we do not have such a triangle. So that is basically how we're going to approach this. All right, so off we go. AC squared is AR all squared. And BC is A squared. AB squared is AR squared all squared. And then we have 2 times BC, which is AB, which is AR squared. And then the cos of angle ABC, and angle ABC is 60 degrees. So that's great. Okay, so let's expand this. A squared R squared is equal to A squared plus A squared R to the 4th minus 2A squared R squared. And the cos of 60 is a half, so that's nice. Okay, let's see what we can do here. Let's put everything on one side, and we will get A squared plus A squared R to the 4th minus A squared R squared, and then minus A squared R squared. Yeah. Okay, so that means this is A squared minus 2A squared R squared plus A squared R to the 4th. Okay, interesting. So what do I do now? Everything has an A squared, so let's factor that out. Let's see if that helps. So that would give me R to the power of 4 minus 2R squared plus 1. And that is very helpful because this guy factors very nicely. It's R squared minus 1 all squared. Okay, great. So that means either A is 0 or it means that R squared minus 1 is 0. So that means R squared would be 1, so R would be plus or minus 1. Okay, let's see if this is possible. A represents a length, right? If you look at the diagram up here, A represented a length. So therefore, A cannot be equal to 0 since it is a length. So this part is no good. But how about this part? This might hold valid. We have concluded that R could be either plus or minus 1. Well, that's not possible because we are told that this is a, what is it? Geometric, right? Geometric sequence is AR squared. And in a geometric sequence, R has to be greater than 1. That's the only way it qualifies as a geometric sequence. So therefore, R cannot be 1 or negative 1. So therefore, since this all falls apart, we can conclude that no such triangle exists with the criteria that they have described in the question. Question number 9. Suppose that m and n are positive integers, with m greater than or equal to 2. The mn sawtooth sequence is a sequence of consecutive integers that starts with 1 and has n teeth, where each tooth starts with 2, going up to m, and back down to 1. For example, the 3-4 sawtooth sequence is as follows. The 3-4 sawtooth sequence includes 17 terms, has an average of 33 over 17 for each of the terms. Part A, determine the sum of the terms in the 4-2 sawtooth sequence. Well, the 4-tooth sawtooth sequence would basically be, remember, this number represents the number of teeth. So there's only 2 teeth here. So we're going 1, 2, 3, up to 4, and back down again. And then another tooth, 1, 2, 3, 4, and back down again. So that's how you would draw it, right? And then they want you to figure out the sum of the terms. Okay, so basically you're just adding up these numbers. So, you know, you're adding 1 plus 2 plus 3 plus 4 and all the way down to this guy. Okay, let's do that. 1 plus 2 plus 3 plus 4. That covers this and this. That's why I put a 2. And then you've got this 2 and this 3 over here. And then you got this 1, 2, 3. whatever way you want to do it, right? It doesn't really matter. So that looks like that's 10 times 2 is 20, plus 6, oh sorry, plus 5, plus 6, so that's 31. And that's it. That's basically part A. Part B. For each positive integer m greater than 2, determine a simplified expression for the sum of the terms in M3 sawtooth sequence. Okay, so that's a little bit different now. So now they're saying you've got another sawtooth sequence, and that is called M3. Now, we don't know M, but we do know 3. And 3 so since 3 represents the number of teeth, that is a very helpful clue to us. And we can therefore draw something, and let's see where it takes us. Okay, so we have 3 teeth, but it starts at 1, but this time it goes up to M. So 1, 2, 3, dot, 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 all the way to M. And then back down again, 3, 2, 1. And then we have to draw 3 of these guys. So 1, 2, 3, dot, 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 all the way up to M. And then back down again, 2, 1. And then one more, 2, 3, dot, 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 up to M. And then back down again, 3, 2, and 1. Okay, so they want you to figure out the sum of these numbers. All right. Well, you all remember that formula that if you have consecutive numbers, 1 plus 2 plus 3, dot, 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 all the way till M, the sum would be M times M plus 1 over 2, right? It's a very famous formula. So that's what we're going to use in this question. Okay, so I'm going to break it up. I'm going to do this guy, and this guy, and then I'll come back to the other guys. So this one right here is essentially this. So it's M times M plus 1 over 2. But I've got 3 of them. I've got 1, 2, 3. So I'm going to put a 3 out here. Got it? Okay, so that's pretty straightforward. Now I've got to concentrate on a few more. I've got to concentrate on this one here, 2 all the way up to M minus 1. So this is a little bit different. This is 2 plus 3 plus dot, 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 all the way to M minus 1, right? So that's going to be M minus 1 times M minus 1 plus 1 all over 2. But there's no 1 here, so I've got to subtract a 1 from that. Does that make sense? Hopefully. Yeah. And then there's 2 of them. There's this one also. So therefore, I've got to put 2 of these guys. So M minus 1 times M, because this becomes M, all over 2 minus 1. Okay, and then I got this one left. That is basically a 1 plus 2 plus 3 plus dot, 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 all the way to M minus 1 scenario. Okay, so that would basically just be M minus 1 times M minus 1 plus 1 all over 2. So that's M minus 1 times M all over 2, because this is just M. Okay, that is the setup, and now I have to simplify this. So I think that shouldn't be too bad. So let's see here. So 3. Can I factor something? I don't know. Well, let's just work with this. 3m times m plus 1 over 2. Let's put the 2 out there. Plus this looks like m minus 1 times m, and then minus 2. Yeah. And then this looks like m minus 1. Well, not much we can do here. So make sure you do the algebra correct. Okay, I think I did. All right, so then if I factor out an m over 2, I probably would have to expand all this. And if I do that, that's going to be m over 2. And then from this expression, I'll get 3m plus 3. And then from this expression, factoring out the m over 2 would just leave me with m minus 1. Yeah, that's correct. And then I've got this stuff, which is going to be m squared minus m minus 2. Okay, it's pretty good progress. All right, so let's simplify this. M over 2 in the brackets, it becomes 4m plus 2. And not much I can do over here. This is going to just stay the same for now. Now I can get rid of that 2. So this is going to be 2m squared plus m. Yeah. And then m squared minus m minus 2. And this becomes, let's see here, 3m squared minus 2. And that's about as far as I can go with regard to simplification. So that takes care of part B. Part C, determine all pairs mn for which the sum of the terms in the mn sawtooth sequence is 145. So this is a little bit different now. So now they're telling you that you've got this big long sequence and the sum is 145. Okay, so we just figured out the general sequence, right? But that was really just for 3 teeth, I believe. 3 teeth or 2 teeth or whatever it was. I think 3 teeth. So it's a little bit more tricky. Okay, so let's talk about this first. Let's draw a sequence. We've got 1, 2, 3, ... all the way till, say, m minus 2, m minus 1, and then, of course, the big guy at the top, m, right? And then back down again, m minus 1, m minus 2, and then ... down to 3, 2, and 1. That's a typical sawtooth pattern just for one tooth. Now what I'm going to do is I'm going to kind of arrange these. I'm going to look at this guy, and I'm going to look at this guy. Now, comparison. So here we go. Let me explain what I'm doing here. First, I'm going to write this number right here. This guy, this 1. And then I'm going to match it with this m. Okay, let me just write that there for now. Then I'm going to take this second guy, and I'm going to match it with this guy, 2 and m minus 1. Then same thing, 3, m minus 2. You guys get the point, ... Eventually down to that one, which is m minus 2, and it would be matched with this. And then the very last one, m minus 1, which would be matched with that. I'm going to leave this 1 here by itself for now. Okay, now the reason I did that is because if you add these guys, each of these will be a sum of m plus 1, right? 2 plus m minus 1 is also m plus 1. 3 plus m minus 2 is also m plus 1, and so on, right? ... These two add to m plus 1, and finally these two add to m plus 1. So that means if you were to add up all of these guys, every single one, it would essentially be a whole bunch of m plus 1s, as you can see. Now, how many m plus 1s? Well, how many did we went from 1 to m minus 1. So m minus 1 of these m plus 1s. So that's the total. Correct? Of just this whole table right here. So that's basically the sum of each tooth. Now, this is what? M squared minus 1. But here's the thing. Each tooth has this sum, but there's n tooths, because we are told that the sawtooth pattern is m dash n, and this represents the number of teeth. So each of these teeth has this sum. So the total sum of all of the teeth would be m squared minus 1 times the n, which represents the number of teeth. But then don't forget about that one that I didn't include. You've got to include that one, because otherwise then it won't work out. All right? So hopefully that makes sense. And they have told you in the question that that is equal to 145. Okay. That's basically the setup of the question. It's this formula that we have to work with. Okay, so let's do that. Simplify this a little bit. n times m squared minus 1 would be equal to 144. And then we're going to make a little table here. M squared minus 1, m squared, m, and let's see what we get. Now, m squared minus 1 can be any of the divisors of 144, right? I think that's pretty straightforward. So 144, 72, 48, 36, 24, and so on. 18, 16, 12, 9, 8, 6, 4, 3, 2, and 1. Okay. Now, m squared would obviously be one more than these guys. So this would be 145, 73, 49, and so on. 37. Now, they told me that m is an integer, right? So that means that m squared has to be a perfect square. That's the only way m could be an integer. So let me just write them all out. 7, 5, 4, 3, 2. Now, which one of these is a perfect square? The only one is 49, 25, 9, and 4. So that would mean m is 7 or 5 or 3 or 2. All the other ones would give you non-integer values. There we go. We got m. So that's good progress. So m is either 2, 3, 5, or 7. So now all we have to do is plug those values of m back into that equation and solve for n. So if m is 2, that's going to be n times 4 minus 1 is equal to 144, and therefore n is 48. If m is 3, it would be n times 9 minus 1 is equal to 144, and therefore n would be 18. If m is 5, that would be n times 25 minus 1 is equal to 144, and therefore n is 6. And finally, if m is 7, it would be n times 49 minus 1 is equal to 144, and therefore n is equal to 3. So my ordered pairs of mn, therefore, would be either 248, 318, 5, 6, and finally 7 and 3. And those are the only ones that satisfy the conditions of the question. Part D. Prove that for all pairs of positive integers mn with m greater than or equal to 2, the average of the terms in the mn Sawtooth sequence is not an integer. All right, so we have to prove that the average of the terms is not an integer. Okay, so not an integer. So that's what we have to show. Okay, so in part C, you guys remember that I had shown that if you have an mn sequence, the sum of the terms, I had come up with a nice formula, is n times m squared minus 1 plus 1, right? That's directly from part C of this question. And in each tooth of the sequence, there are a certain number of terms. There are m minus 1 plus m minus 1, which is 2m minus 2 terms. Right? Let's see if I can refresh your memory. So this is a tooth. Here's m minus 1, and then this is also m minus 1. Remember, we don't count this guy. We count it at the end. So this is m minus 1 terms, this is m minus 1 terms. So that's how we got that 2m minus 2. All right? And in the total sequence, you have, therefore, since there's n teeth, you take this and multiply by n. And then remember, don't forget that lone 1 that I forgot to add at the very beginning. that I didn't add purposely. And this is the total number of terms. So the average would therefore be, you guys know how to figure out the average, the sum divided by the total. The sum, which is right here, which is n times m squared minus 1 plus 1, divided by the total number of terms, which is right here, n times 2m minus 2 plus 1. This is the average. And they're saying, prove that this is not an integer. So let's say it is an integer, where k is some integer. Let's say it is an integer, and let's see what happens. If it's not an integer, then this will fall apart, like it won't work for some reason. Okay, so let's see what happens. Why doesn't it work? All right, well, we got to simplify this. So here we go. Off we go. So what we have here is m squared n minus n plus 1. And then on the bottom, I've got 2mn minus 2n plus 1. And that's all equal to k. Okay. Cross multiply, and I get 2, or actually there's no 2, m squared n minus n plus 1. And I've got 2mnk minus 2nk plus k. So a lot of variables here. Okay, let's make this into a quadratic, like at least put it in that form. So I've got n as a coefficient, m squared. Then I've got 2nk as a coefficient for m. And then I got a bunch of stuff that doesn't have m in it. So 2nk minus n minus k plus 1. And that equals 0. So this is a quadratic equation, basically. And m is an integer, as they said in the question. So if it's an integer, if m is an integer, then that means the roots of this equation are integers. Okay? And the only way the roots of something are integers is if the discriminant is a perfect square. So you guys remember, if you have a quadratic ax squared plus bx plus c is equal to 0, quadratic formula states that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, right? And this is the discriminant right here. The discriminant, I'll just call it d, is b squared minus 4ac. And if that is a perfect square, then x will be an integer. If it's not a perfect square, then x will be some combination of numbers and square roots. Got it? Okay, so we got to show that the discriminant is a perfect square for that. All right, so let's see, what is b squared minus 4ac in this one? It looks to me like 2nk squared. Remember, we're concentrating on this guy. Minus 4n times this whole big long thing for c, 2nk minus n minus k plus 1. And this has to be a perfect square, so it's got to be like some whatever, t squared. I'm just calling it t. You can call it anything you want. All right, let's see what happens. When we simplify this, we get, what do we get? Well, we get a big long expression, and then I'm going to simplify it into its final form. And I'll let you guys simplify it, but I'm going to put it in its final form when it's all nice and factored. As you get this, you get 2n times k minus 1 plus 1, all squared, and minus 1. And that is equal to some, it's a perfect square. Now, the only way this would work is if a couple ways. The first way is if this guy is equal to right here, this part of the expression is equal to 1. So that would mean that 2n times k minus 1 plus 1 all squared is equal to 1. Because if that's equal to 1, then it would be this minus 1 would make it 0, and 0 is a perfect square, right? So let's see if this can work. If that is equal to 1, then that means that 2n times k minus 1 plus 1 can be equal to 1, right? When you take the square root. And therefore, 2n times k minus 1 is equal to 0. So that means either n is equal to 0 or k is equal to 1. Correct? Well, n can't be 0, right? Because if n is 0, there's no teeth. That wouldn't make much sense. So let's just concentrate on this k equals 1 part. If k equals 1, then I can go back to this and sub k equal to 1 and see what I get. So if k equals 1 and I substitute that into that equation, I will get that m squared n minus n plus 1 over 2mn minus 2n plus 1 is equal to 1. And therefore, when I cross multiply, I get m squared n minus n plus 1 is equal to 2mn minus 2n plus 1. Put everything on one side, and we get m squared n minus 2mn. I think this would be plus n, and then the 1's would cancel. And then I can factor out an n from this, and this is going to be m squared plus 1 minus 2m. And this in the middle here factors very nicely to m minus 1 all squared. So again, finally, we get to, again, a n equals 0 or m equals 1. Now, n cannot equal 0, because if it did, there'd be no teeth, basically. And m cannot equal 1 because one of the criteria is that m has to be greater than or equal to 2. So therefore, we have proven that this whole process falls apart when you try to create the average as an integer. So we have proven that therefore the average of such a sawtooth pattern cannot be an integer. At Pizza by Alex, toppings are put on circular pizzas in a random way. Every topping is placed on a randomly chosen semicircular half of the pizza, and each topping's semicircle is chosen independently. For each topping, Alex starts by drawing a diameter whose angle with the horizontal is selected uniformly at random. This divides the pizza into two semicircles. One of the two halves is then chosen at random to be covered by the topping. For a two-topping pizza, determine the probability that at least 1/4 of the pizza is covered by both toppings. All right, so we've got, let's work with this now. So we cut it in half, right? And we put the first topping in the first half. So T1. All right, great. So far, so good. And then we have to cut it again at some angle. And then we have to now put our T2 in that half. So if T1 was somewhere in here, we're going to put T2 somewhere above this line. So whatever, let's say it goes here. Got it? Okay. So we've got to now talk about some scenarios with regard to this angle, which I will call theta. Okay, so let's see here. What scenarios? We've got 1 scenario, 2 scenario, 3 scenario, and 4 scenarios, I believe. And that should be it. The first scenario is if theta is anywhere between, say, 0 and 90. So that basically means that this was the first half, and then the second half is this guy. Now, if you look closely, T1 and T2 are in at least 1/4 of the circle. So if this is T1, this is T2, T1 and T2 are in at least 1/4 of the circle. And that's for that range for theta. And you can try it. You can kind of, where angle is like from there to there. If it's 45, if it's 60, blah, blah, blah. It's always going to be 1/4. Okay, so now let's move on to another scenario. What happens if theta is no longer in that category, but between 90 and 180? Now we've got this scenario that this theta is something like this. So you've got initially this section for T1, and then for T2 you got this section. So now T1 and T2, say T1 and T2 like that, T1 and T2 now are in less than 1/4 of the circle. Got it? So that's no good because we want it to be at least 1/4. Okay, let's keep going here. What happens in this scenario? Well, theta is between 180 and 270. Well, now the theta is, let's say something like this, where this is theta from here to here. So as you can see, it's greater than 180. So first you had that area, and then you had the second area, which is this guy right here. Now my T1 and T2, here's T1 up here, and T2 is down here. So again, T1 and T2 are in less than 1/4 of the circle. Less than 1/4 of the circle. And then finally, the very last scenario, which is when theta is between 270 and 360. That is scenario something like this, where now this is the whole theta right there. So you had first T1 there, and then your T2 is going to be in that section right there. So if you're going to draw T1 and T2, T1 would be somewhere here, and T2 would be somewhere here. So now T1 and T2 are in at least 1/4 of the circle. So which ones are we interested in? We want this one and this one. So we want this guy and this guy. So when theta is between 0 and 90, or between 270 and 360. So this is a 90-degree range, and this is a 90-degree range. So you have 90 plus 90. And the total range for all of them is 360 degrees. So this is 180 over 360, and therefore that is 1/2. And that is the probability that you will have T1 and T2 in at least 1/4 of the circle.